Sarcoidosis is a disease characterized by granulomas, which are collections of immune cells caused by chronic inflammation that can form in our lungs, lymph nodes, on our skin, and in other parts of our body. The occurrence of sarcoidosis varies greatly around the world, from fairly low levels in countries like South Korea, Taiwan, and Japan, to up to 100 times higher levels in Sweden and Canada. Race also seems to matter, with Black populations experiencing much higher rates of disease and higher rates of death at younger ages. It's possible Black people may be at greater risk of disease and disease severity, but there are also long-standing systemic health and social inequities that limit access to quality care. The routine way to treat sarcoidosis is with immune-suppressing corticosteroid drugs to manage the inflammation. Drugs come with their own limitations, though, including steroid resistance, no response to the medications, and a long list of potential side effects. Could nutrition help in sarcoidosis treatment? Possibly. Certain components in food may have anti-inflammatory effects in lung diseases. So maybe sarcoidosis patients should be encouraged to eat antioxidant and polyphenol-rich diets. But there have yet to be interventional trials to put it to the test. Are there any steps we can take to potentially avoid this disease? Its cause is unknown. Sarcoidosis can cluster in families, but maybe that's just because of a shared household environment. Although some gene variants may increase susceptibility, genes alone are insufficient to cause sarcoidosis. Something is driving the disease process. Something is driving the inflammation. We may be closer to solving one part of the mystery of sarcoidosis. Recent advances in molecular and immunological methods have produced a more rigorous look at the drivers of the disease, indicating that mykobacteria are likely involved in at least a subset of sarcoidosis cases. Mykobacteria like Mycobacterium avium paratuberculosis, or MAP, MAP, is a zoonotic pathogen, meaning it can go from animals to humans. We previously covered the potential link between MAP and other autoimmune conditions, like type 1 diabetes, and how dairy products are a major exposure source in our diets to MAP. Viable MAP bacteria are still being found in pasteurized milk, despite efforts to extend the pasteurization processes to prevent this. It's also found in goat milk and various types of cheeses, Swiss, cheddar, sheep, and goat cheeses, along with softer cheeses like mozzarella and burrata. Unfortunately, this is a global issue in countries raising cows in intensive systems, with among the highest rates in the United States, where 68 to 91% of dairy herds are infected. In this 2015 review, 2 studies looked for MAP bacteria and found none in either sarcoidosis patients or control subjects. And 2 other studies looked at evidence of MAP exposure and found between 7 and 17 times the odds of reacting to MAP, but neither reached statistical significance. What have we learned since then? In a natural experiment, researchers looked at the rates of sarcoidosis among those who did or did not receive the BCG vaccine, which provides partial protection against mycobacteria like tuberculosis. And those born during a time with high BCG vaccination uptake had lower rates of sarcoidosis. But it's not like it was a randomized controlled experiment, so it's not clear if tuberculosis vaccination could really protect from MAP-associated autoimmune diseases, which also include Crohn's disease, Hashimoto's thyroiditis, MS, rheumatoid arthritis, and lupus. The strongest evidence would come from seeing an effect from treating someone with antimycobacterial drugs. That's how Barry Marshall got the Nobel Prize for proving that H. pylori caused stomach inflammation by swallowing some, then curing himself with antibiotics. This is a study that excited the sarcoidosis community. Cardiac sarcoidosis, meaning sarcoidosis of the heart, resolved with MAP antibiotics. MAP was first identified in this patient's blood, and after more than a year of a MAP antibiotic regime, his sarcoidosis appeared to disappear, something that was never even thought possible. A pilot study in those with pulmonary sarcoidosis also found impressive results with antimycobacterial therapy, with improvements in lung function and quality of life. When the researchers conducted a larger trial, however, there was no significant benefit for lung function, despite a significant reduction in mycobacterial immune responses. So, where does that leave us? Mycobacterial avium paratuberculosis in the food supply is a public health issue. To reduce human exposure to MAP via consumption of dairy and meat products, more studies are needed for estimating how much MAP is in the milk, meat, and feces of these animals, and how much fecal contamination is in the milk and meat, to figure out what we need to do to kill it.
Více.